What does it mean for a species, confined to a single, fragile world, to cast a message into the cosmic ocean? The Voyager mission is more than scientific inquiry. It's a profound expression of our curiosity and longing for connection. These twin spacecraft, launched nearly half a century ago, have traveled farther than any human-made object in history. They are our silent emissaries, carrying a record of our world, our sounds, and our hopes. As we stand here today, August 7, 2025, the faint signals from these probes are nearly lost in the cosmic background. The final transmission is not a matter of if, but when. Voyager's ultimate fate is to wander the galaxy for eons, its instruments silent, its power depleted, but its journey unending. The spacecraft are a reflection of our cosmic loneliness and our audacious hope that we are not alone. The story of the last signal is a mirror to our aspirations and limitations, a humbling reminder of the scale of the cosmos. As we prepare for this final, faint message to cease, we reflect on the legacy of this grand adventure and how it reshaped our understanding of home. The Voyager mission was born from a rare celestial alignment in the late 1970s, when the outer planets lined up for a once-in-176 years grand tour. NASA seized this fleeting opportunity, designing two robust robotic explorers. Voyager 2 launched first, followed by Voyager 1, each on a unique trajectory to maximize their planetary encounters. Voyager 1's primary mission, study Jupiter and Saturn in unprecedented detail. Voyager 2, the full grand tour, visiting all four outer planets. The design was a masterclass in resilient engineering, with each probe carrying 11 scientific instruments and powered by 3 radioisotope thermoelectric generators. At launch, reaching interstellar space was a distant dream. The goal was to capitalize on the alignment and complete the first reconnaissance of the outer solar system. The engineers built for a 5-year mission, but inadvertently crafted vessels capable of surviving for half a century and reaching the stars. These launches marked the beginning of a multi-generational journey, a relay race against time and distance. Voyager's endurance is a testament to human ingenuity and vision. The first major destinations were Jupiter and Saturn, the gas giants that would redefine our understanding of the solar system. In 1979, both Voyagers swept past Jupiter, sending back stunning images of the Great Red Spot and discovering faint rings and volcanic activity on Io, the first active volcanoes found beyond Earth. These discoveries shattered old paradigms, revealing moons as dynamic worlds. The probes continued to Saturn, arriving in 1980 and 1981, unveiling the planet's intricate ring system and discovering new moons. Voyager 1's close flyby of Titan confirmed its thick, nitrogen-rich atmosphere, reminiscent of early Earth. The mission's instruments detected lightning, mapped magnetic fields, and measured atmospheric composition, fundamentally rewriting textbooks. Gravity assists at Jupiter and Saturn propelled the spacecraft onward, Voyager 1 toward interstellar space, Voyager 2 toward Uranus. Each flyby was a high-stakes, precisely choreographed event, executed across hundreds of millions of kilometers. The data revealed the outer solar system as a dynamic, diverse environment, challenging our models of planetary evolution. The Grand Tour's early chapters set the stage for the discoveries to come. After Saturn, Voyager 2 alone pressed on to Uranus, becoming the only spacecraft to visit this tilted, enigmatic ice giant in 1986. It discovered new moons, rings, and a bizarre sideways magnetic field, revealing a bland blue-green world with hidden mysteries. The journey continued to Neptune in 1989, where Voyager 2 captured the Great Dark Spot and discovered more rings and moons. Triton, Neptune's largest moon, stunned scientists with geysers erupting from its icy surface, evidence of cryovolcanoes in the deep cold. These encounters expanded our understanding of where geological activity could occur, pushing the boundaries of what we considered possible. With Neptune's flyby, the Grand Tour ended, but the mission's ultimate journey was just beginning. The Voyagers had surveyed all 4 giant planets, providing a foundation for planetary science that endures today. Their data continues to inspire new generations of researchers. The planetary phase was over, the next frontier was the vast, uncharted territory beyond the sun's reach. Voyager's odyssey was far from finished. Affixed to each Voyager is a golden phonograph record, a time capsule for any intelligent life that might one day intercept the probe. The Golden Record, conceived by Carl Sagan's team, contains images, sounds, and music meant to portray the diversity of life and culture on Earth. It includes 115 images, greetings in 55 languages, and sounds from nature and humanity, whale songs, a baby's cry, a rocket launch. The music spans Bach to Chuck Berry, traditional songs from around the world, and a Navajo night chant, capturing the emotional and intellectual richness of our species. The record's cover is etched with instructions and a pulsar map, a galactic address pointing to our sun. Whether these symbols could ever be deciphered by alien intelligence is unknown, but perhaps the record's true audience is ourselves, a reminder of our attempt to reach out and say, "We were here." The golden record is a message in a cosmic bottle cast into the ocean of stars. It is both a greeting and a monument to our hope. Voyager carries our story into the unknown. After their planetary tours, the Voyagers began their final phase, the interstellar mission. Their goal was to explore the edge of the sun's domain and become the first human-made objects to enter interstellar space. In 2012, Voyager 1 crossed the heliopause, confirmed by a dramatic increase in plasma density, proof it had left the sun's bubble. Voyager 2 followed in 2018, providing invaluable comparative data and the first direct measurements of interstellar plasma. The heliopause proved to be a dynamic, porous boundary, shaped by the solar and interstellar winds. Now, in 2025, both spacecraft continue deeper into the Milky Way, over 20 billion kilometers from Earth. Their signals take over 22 hours to reach us, a stark reminder of the scale of their journey. The Voyagers are now our remote sensors, sampling the galactic environment firsthand. Voyager's longevity is a triumph of 1970s engineering, but its operational life is finite. The main constraint is power. The plutonium in their generators decays, producing less electricity each year. Engineers have shut down non-essential systems and heaters, prioritizing key instruments to extend the mission. Each shutdown is a calculated sacrifice, keeping at least one instrument alive as long as possible. Communication is the final hurdle. Their 23-watt transmitters now whisper across billions of kilometers, barely detectable by Earth's deep space network. Eventually, the power will drop too low, or the signal will fade into cosmic noise. There will be no dramatic farewell, just a gradual fading into silence. The link will break and the Voyagers will continue their journey alone, carrying the golden record into the galactic night. Their mission of exploration will end, but their odyssey as cosmic artifacts will endure. Voyager's silent voyage will outlast us all. Voyager's scientific return is immeasurable, transforming our view of the solar system from a collection of planets to a complex system of worlds and rings. Its discoveries, volcanic Io, Europa's ocean, Titan's atmosphere, Triton's cryovolcanoes, opened new fields of research and inspired future missions. Voyager's data extended to heliophysics, mapping the solar wind and confirming the heliopause. The mission's technology, autonomous systems, deep space communication, gravity assists, set new standards for exploration. Its software was reprogrammable from billions of kilometers away, a feat for its era. Voyager's greatest legacy may be cultural: the pale blue dot image, a humbling portrait of Earth as a fragile speck in the cosmos. The mission is a story of curiosity, ingenuity, and reflection. Voyager reminds us of our shared place in the universe. The Voyager mission stands as a monumental achievement in human exploration. For nearly 50 years, these twin probes have revealed a universe more complex and beautiful than we imagined. They discovered volcanic moons, measured planetary storms, and crossed into interstellar space. Their scientific legacy will be studied for decades. Their cultural legacy is a symbol of hope and connection. The golden record is our greeting to the cosmos, and the spacecraft themselves are our silent, eternal monuments. The impending silence is not an end but a transition. Voyager's endless journey as an ambassador to the stars. The mission mirrors our own journey: departure, discovery, and a voyage into the unknown. As the last signal fades, Voyager's legacy asks, now that we've stepped into the interstellar ocean, where will we go next?